dryer. First introduction. So the general idea about this research is the high consumption of wet flour. Importing wet flour or starch has become food security issues. Cassava starch has a potential to substitute wheat starch by modifying its properties. The process involves the use of lactic acid in hydrolysis and drying using UV light dryer. This process will enhance the baking expansion ability of the cassava starch. So, the aim of this research is to study and discuss the influence of lactic acid and UV irradiation toward cassava starch. The research will focus on the physicochemical and rheological properties of modified cassava starch. So, starch is a mixture of two polysaccharides. Starch is a mixture of two polysaccharides, the linear molecule of amylose and branch polymer of amylopectin. This is the table of variation type of starch and the state of granule of each variation, granule size, crystallization, gelatination temperature, and swelling power. So its positive attributes of starch and the function is heavily influenced by these two important components, which is amylose and amylopectin in the granules. Cassava starch is an important food crop in Indonesia and has the potential to be developed as a substitute of flour, but the starch granule characteristics are needed to be changed so that the ability to expand can be enhanced. Cassava starch has the physical properties of this table: swelling power of 28.7, solubility percent of 29.7, carboxyl group of 0.03%, carbonyl group of 0.07%, and viscosity of 400. It has starch content of 73.3% and amylose content of 17%, and amylopectin is 83%. The size granule is semi-spherical granule with a size of 5 vary between 5 and 3.5 micrometer. Temperature of gelatinization is vary between 52 until 64 degrees of Celsius. So in this research, we used to modification process. The first modification process is starch modification, lactic acid hydrolysis. This is a chemical modification process that can significantly change the structural and functional properties of starch without disrupting its granular morphology. And the next is starch modification using UV irradiation using Rotary UV dryer. This modification is in the process of the degradation of starch granule in ultraviolet or UV irradiation that could change the porosity and surface area of the granule and will determine their properties. So the experimental process, the first process is hydrolysis process. In this process, modified tapioca starch is made by mixing cassava starch of 500 grams into lactic acid solution with concentration of 0.5% and 1% into a stirred reactor at room temperature with the duration of 30 minutes. This is the picture of the hydrolysis process. And then to the drying process, before that, we have to separate the starch and lactic acid solution through screening. So in the drying process, the drying temperature is 65 degrees of Celsius and 75 degrees of Celsius with the rotational speed vary between them. This is the picture of the rotary UV drying that I use. So the analysis, I have to analyze the swelling property of the starch, and then the carboxyl group analysis, and then the volume expansion, the solubility, and then the carboxyl group. This is the result. So with variation of temperature of 65 and 75 degree, and rotational speed of 8, 10, and 12 rpm, with lactic acid concentration of 0.5% and 1%. The parameter is the density, swelling power, solubility, carboxyl and carbonyl group, and then the expansion ability. So this is the result of the swelling power. We could see the highest value of the swelling power is 14.8 gram per gram at a concentration of lactic acid of 1% and temperature of 75 degrees Celsius. This is because high concentration of lactic acid will result in highest swelling power. And then for the solubility, you could see that the highest value, that is 20.4% at 1% concentration, temperature of 75 degrees Celsius. This is because in acid modification, acid acts on the surface of the starch granule first before it gradually enters the inner region, the granule. So it changes the physicochemical properties without destroying its granule structure. But because of the structural properties of the amylose and amylopectin content in the modified cassava starch, the ability of starch to dissolve in the water is higher, and thus the hydrolysis results in higher solubility and swelling power. For the carbonyl and carboxyl group, we can see that the carbonyl and carboxyl group are influenced by the temperature. It's heavily influenced by temperature, not really in the lactic acid concentration or the rotational speed of UV dryer. So the rotational speed of the UV dryer didn't give significant change, didn't give significant influence in the carbonyl carboxyl group or either the swelling power or the solubility. For the expansion ability, the highest value is at 1% concentration and temperature of 75 degrees Celsius and rotational speed of 12 rpm. It is the sample of 12. You can see that the highest is 27%. For the SEM analysis, we compare between the pure cassava starch, the cassava starch before modification, and the modified cassava starch, the cassava starch after the modification. So we can see that the pure cassava starch is smooth without starch, and on the modified cassava starch, it is extensively eroded by many cracks and have some irregularity. And then on the modified cassava starch, it looks that it is smaller than the pure cassava starch. And then for the FTIR analysis, this is the result. This is for the modified cassava starch and the comparison between the pure cassava starch. Pure cassava starch and modified cassava starch has the same functional group, so it didn't have so many difference between the pure and the modified. Maybe in just the peak detected on the carbonyl and carboxyl group that's slightly different, only little different. So we can conclude the difference of cassava starch, modified cassava starch, and wheat flour based on the parameter like swelling power, solubility, carboxyl and carbonyl group, and volume compression or volume expansion. We could see that the modified cassava starch is much more similar in the wet flow. So we could say that the cassava starch that has been modified could be used as a substitute of the wheat flour. This is the modified cassava starch with the result of the best result of the previous data. So in conclusion, modified cassava starch with lattice hydrolysis and the UV rotary dryers has the best results they obtain at variable rotational speed at 12 rpm, the temperature of 75 degrees Celsius, and the concentration of 1%, with the result of swelling power level, volume compression or expansion ability, solubility, carboxyl and carbonyl group, respectively, are 14.08 gram per gram and 2,700% and 15.7%. And then for the carbonyl and carboxyl group are 0.252% and 0.206%. Thank you for your attention. This is the end of my presentation. Thank you, Professor Andri, for giving me time.
Okay, thank you very much, Alifa, for your presentation. So, any comment, any question from us for Alifa and her research before she goes to the